This is the last in the series of videos on acids and bases, and in this video we're going to talk about neutralization reactions, which is what happens when you put an acid and a base together in solution, and then how we use that neutralization reaction to do something called titration, which is using acids or bases of known concentration to find the concentration of unknown acids and bases. So the first thing is, what is a neutralization reaction? Well, when you have an acid, which can be either written as H3O plus or just H plus, and you have a base, which has the OH ions, when those two things combine, H and OH, you end up with H2O, or water. Obviously, water is neutral, so when you combine the hydrogen ions from the acid with the hydroxide ions from the base in the same solution, they neutralize each other and form water. Another thing to look at here is these ions don't just come from nowhere, unless you're starting with water, in which case it'd be neutral anyway, but usually they're produced by a certain other compound like HCl and say LiCl. Let's do LiOH. Okay, so the acid is HCl, the base is LiOH. Now, when they react, one of the products, which we're going to see here, right, is water, because the H from the HCl and the OH from the LiOH combine to form water. And then the other product is going to be lithium chloride, which is a type of substance called a salt. Okay, so we talk about salt is not just table salt, sodium chloride, but it's any combination of a metal and a nonmetal. Okay, so the products of a neutralization reaction are always water and salt. Doesn't have to be NaCl, but salt, metal, nonmetal combination. So when you neutralize an acid and a base, because the acid usually has a nonmetal, right, like a chloride or an iodide or a fluoride, or it could be a polyatomic ion like a sulfate. And the hydroxide is almost always bonded to a metal, typically an alkali metal or an alkaline earth metal. So the metal and the nonmetal or the polyatomic ion get together to form this type of compound called salt. So you get water and salt out of a neutralization reaction. Here's another example. MgOH combines with HCl to give you magnesium chloride, which again is a type of salt. It's one of the common ice melt salts, and water. So that would be a neutralization reaction. Titration. Yeah, as I mentioned earlier, titration is taking an acid or a base, depending on what you're working with, of known concentration. So you create an acid with a specific concentration so that you know how concentrated it is and you know how much you have. And we're going to use that to determine the concentration of an unknown base if you're starting with an acid. Why do that? Okay, take the known solution, which is called the titrant, and the unknown, and you go to what's called the equivalence point. Now, the equivalence point is the point at which the hydrogen ions has equaled the hydroxide ions. You've neutralized all of the base, if we say we're starting with an acid. So since you know how many moles there are per liter of the hydrogen ions in your known acid, if you measure how much acid it takes to neutralize that base, you can then calculate how many hydroxide ions there were, and depending on how much you have, you can figure out what the number of ions per mole would be, and therefore the concentration of the base. And the way we do this, since we can't, sit there and count the hydrogen and hydroxide ions individually, is we use what's called an indicator, a chemical dye, and you might have used these in biology, but a dye whose color is dependent on whether it's in the presence of an acid or a base. And so if we start with it in a basic solution and it's one color, and then it changes as soon as it turns into an acid, we can mark the point at which the color changes and say, oh, that's where it was neutralized, and then we can do our measurements of how much acid did it take to neutralize that quantity of base, and we can determine what the concentration of the base was. And again, this works the other way around. If you have an acid that's unknown, you can use a base of a known concentration. And so the end point of a titration is when the indicator actually changes color. So indicators change color at different pHs, so you can choose different indicators depending on what you're doing. And so the equivalence point, which again is basically when you've reached neutralization, is not necessarily the same as the endpoint, depending on the indicator you use. But if you use the right indicator, the endpoint should be the same as the equivalence point, because you want that color to change right when the solution goes from base to acid or acid to base. And you know, oop, that's right at that point is where you've hit the neutralization, the equivalence point. So you take a known volume of an unknown concentration. That's key. You have to know how much there is, because it's moles per liter, and we need the milliliters, even if we don't know the moles yet. We're going to find that out. And you put that into a flask or a beaker with an indicator, so it turns a certain color. It's either clear to start with, or it might be pink to start with. Those are typical acid-base indicator things. And so if it starts out clear, it's going to change and suddenly turn pink. If it starts out pink, it might suddenly turn clear or change to a yellow or a green color. Okay, and then you fill a burette, which is a long tube that dispenses of very precise quantities of liquid. So then you put your known concentration in there, and also the burette has markings on it like a graduated cylinder, so that you'll know exactly how much of the known stuff you dispensed. Okay, and then you add the known concentration stuff to the unknown concentration until it changes, until it reaches the equivalence point. Once you do that, you can say, all right, if it took 1 liter of 1 molar solution to neutralize the unknown, you know that you neutralized 1 mole of hydrogen or hydroxide ions. And then you can figure out if that was 1 mole in 1/10 of a liter, then it was a 10 molar solution. So the moles of acid neutralized is equal to the moles of base used. And again, as we mentioned, it would be ideal if the equivalence point and the end point for the indicator are the same, because then you get that visual check of, okay, it's changing color. I know I've neutralized my acid or my base, therefore I can stop, I can calculate how much stuff was used, and figure out what the concentration of the unknown was. So that is it. That is the end of the notes on acids and bases, and that is the end of the notes for the year. So from this point on, we're going to be reviewing this material as well as going back and doing review for the final exam.